Our learning target, I can identify the oxidation number for the representative elements on the periodic table. So you'll need your periodic table in just a minute. An oxidation number is a charge on your ion, a positive or negative charge, and we can use our periodic table for general patterns. So here's your periodic table, so make sure you're labeling things as we go through. So the alkali metals in the first column all have a +1 charge. The alkaline earths all have a +2. Now we're going to skip the transitions. We're going to go over here to boron. Column 13 has a +3. Skip your carbon family, okay, because they don't follow the rules. Nitrogen family has -3s. Chalcogens, column 16, are -2s. Your halogens in column 17 are -1s, and your noble gases are 0. They don't react. Now let's talk about the transition metals here. They have multiple charges, except for zinc is always +2. Label that. Cadmium is always +2, and silver is always +1. Now remember that these guys under here are also part of the transition metal family, the indium, tin, and antimony, thallium, lead, and bismuth. So they're going to have varying charges also. Alright, so our next learning target, I can write formulas for the ionic compounds using the charges. Remember, the charges are the most important part. So what we do is we first of all determine the charge of the ion. We're going to look at our periodic table for that. Got to do this, guys. Got to do it. Then you're going to determine the ratio. Remember that you flip them. Okay, so for example, if we have calcium with a +2 and chlorine with a -1, our ratio is 1 to 2. Alright, so we've flipped those. So my formula becomes CaCl2. Let's look at a couple more examples. Potassium oxide. So the first thing we need to do is look at potassium on the periodic table. That's an alkali metal. In the first column, it's going to have a +1 charge. Oxide is oxygen. That's a chalcogen, so it's going to have a -2 charge. Now to get the ratio, we're going to flip those. So our ratio becomes 2 to 1. So the 2 came from the charge of our oxygen. The 1 comes from the charge of potassium. So our formula is K2O. Magnesium hydroxide. Magnesium is an alkaline earth metal, column 2. So those guys are +2s. Hydroxide is a polyatomic ion. It's on your orange sheet that we got in class. It's OH with a -1 charge. And you have to write it that way, put your parentheses around it. So the ratio, when we flip them, becomes 1 to 2. There's our 1, there's our 2. So our formula becomes MgOH2. Guys, the parentheses have to be there. Iron 2 phosphate. Now iron is a transition metal, so we can't tell its charge just by looking at the periodic table. So what they do is they tell us in the name. This Roman numeral 2 tells me that I have a +2 charge. Now phosphate, ATE, means it came from my orange sheet. That's PO4 with a -3 charge. So my ratio, I'm going to flip those. I'm going to get 3 to 2. There's the 3, there's the 2. So my formula becomes Fe3, PO4 in parentheses, 2.